Alright, in this lecture we are going to solve the weekly challenge 1 from AppMillers Tech Community. So here it says that we need to write a function that rotates an array to the right by k step, and we have provided example over here. So what I'm going to do, I'll just go ahead and put this one in the slides, and this will make things more clearer. So as I mentioned, we need to write a function that rotates an array to the right by k steps. First, we need to understand what this exercise says. So as an example, we have an array over here. So let's say k in this case is 2. So if we rotate this array by 2 steps, it's going to become like this. So this means that the elements will be moved right 2 steps. So the index of 1 is 0. Now if we add 2 to that index, it's going to become index of 2. That's why it's going to move to the index of 2. So the initial array is like this. So after rotation, it's going to become like this. So 1 will move 2 step right, then 2 will move 2 step right, then 3 will move 2 step right. Now when it comes to the 4, we see that if you move it 2 step right, it's going to become at the index of 6. So we don't have index of 6. So this means that it's going to become to the beginning of the array. So this is the first step. And the second step is going to be like this. Now, this is applicable for the last element also. So it's going to move to the place of index of 1. Because if we take 2 steps, it's going to become to the place of index of 1. So that's how it's going to look like after the rotation. Now, let's look at the function in Python. So the code is going to be like this. Now, I'm just going to debug the code to show you how this is going to work. So the execution will start from the first line. So as a first parameter, let's say we are passing this array and the k is equal to 2. Now the first step is we are going to find out the length of the array. Now in our case, the length of array is 5. Then we are going to find the remainder after dividing the k by n. Now in our case, k is less than the length of array. That's why it's going to return the k itself. Now if someone passes a parameter over here, the value which is greater than the length of the array, in this case, we need to adjust that k, which is going to become the less than n. So in our case, k is already less than n. That's why it's not going to be adjusted. It's going to remain as 2. Then we will continue to the next line of code. Now in this line, we are reversing the array. Now if we reverse the array is going to become like this. So before 1 was the first element, now it is the last element, and 5 was the first element, now it is the last element. Then after doing so, we are going to take this part of array, which is starting from the 0th index until the k index. Now k is 2, so this means that this is going to be excluded. So it's going to take only elements which are located at the index of 0 and 1. Then after taking this, we are going to reverse that elements. So if we reverse them, it's going to become like this. So we are going to change their places. Then the next thing that we are going to do, we are going to take the other part of the array. Now the other part of array is going to be like this. So it's going to start from the index of k until the last element. Now the k is 2 until the last element is going to become the end of array. So similarly, we are going to reverse this part of array. So after reversing, we have reached to the solution. So this means that we have rotated this array by k step. So before 1 was located at the index of 0, now it is located at the index of 2. And 2 was located at the index of 1, now it is located at the index of 3, and it continues like this. So as you can see, with these steps, we have successfully solved this problem. Now let's look at the time and space complexity for this function. So here we are going to start from the first line of code. So in the first line, we are finding the length, which is going to take the O1 time complexity. Then we are dividing k by n and finding the remainder by using the modulus operator. So this is constant time operation. That's why it's going to take O1 time complexity. Then we are reversing the array. So if you use the reverse method of the Python, it's going to take On time complexity, where n is the number of the elements in the array. Similarly, this is applicable for this. Here we are using the k number of the elements. So that's why the first reverse is going to take OK time complexity, and the second one is going to take On minus k time complexity, because in the first we have the k number of the elements, and in the second we have the n minus k number of the elements. Now if we combine all these complexities, it's going to become On time complexity, because here we are excluding the non-dominant terms. So total time complexity is On, and the space complexity is O1, because here in place reversals are used meaning that no extra array or data structure is created for this operation. That's why space complexity is O1. So hopefully everything is clear about this exercise.